The objective of this lesson is to introduce you to some of the essential communication protocols used in IoT and to highlight the importance of security when designing and deploying IoT systems. This lesson will provide an overview over key IoT protocols such as MQTT and RESTful APIs and emphasize security's best practices. It helps you understand how to protect your devices and data in the growing world of connected devices. As your experience with IoT grows, you will find that communication and security become increasingly important. Your IoT project is part of a larger ecosystem where devices need to talk to each other efficiently, reliably, and securely. Whether you're sending data between cloud servers and sensors or controlling devices remotely, it is critical to choose the right communication protocol and ensure that your device is secure. This lesson will introduce you to some of the most commonly used communication protocols in IoT and discuss basic security measures that should be implemented to safeguard your device. IoT systems rely on communication protocols to exchange data between devices, cloud servers, and user interfaces. Two of the most widely used protocols in IoT are MQTT and RESTful APIs. MQTT, or Message Queuing Telemetry Transport, is a lightweight messaging protocol designed for IoT devices. It's optimized for low bandwidth and high latency networks, making it an excellent choice for resource-constrained devices, like the ESP32. MQTT operates on a publish-subscribe model, where clients or devices publish data to specific topics or subscribe to topics to receive data. This model is efficient and scalable, especially in systems with multiple devices that need to communicate with each other. Imagine you have multiple sensors in different rooms. Each sensor can publish data to a topic like home/living room/temperature, and other devices or even a cloud server can subscribe to this topic to receive real-time data without constant polling. MQTT requires a central broker, such as Mosquito. This is used to manage the message distribution between devices. The broker ensures that the data published by one device is routed successfully to all subscribers. MQTT is commonly used in smart home systems, environmental monitoring networks, and industrial IoT applications due to its low resource usage. RESTful APIs, or representational state transfers, are more of a traditional approach in communication with IoT systems. They are particularly used for devices interacting with web services. In REST, devices send HTTP requests, such as get, post, put, delete, to a server. The server then responds with the requested data or action. RESTful APIs are widely used because they are stateless and because they leverage the standard HTTP protocol, which is easy to implement and widely supported. For your IoT project, you can use the RESTful API to send data to a cloud-based server or retrieve information from a web-based database. For example, your ESP32 could send temperature and humidity data to a cloud server that would then serve the data via a web interface. RESTful APIs typically use JSON, or JavaScript Object Notation, as the data format for communication. It is lightweight and easy to read by both humans and machines. While RESTful APIs are powerful and flexible, they can require more bandwidth resources than MQTT, which may not be ideal for low-power IoT devices with limited connectivity. Let's go over the importance of security. Security is a critical consideration in IoT because connected devices often have access to sensitive data and control other physical systems. Without proper security measures, IoT devices are prone to hacking, data breaches, and unauthorized control. Let's go over some fundamental security practices you should consider when developing and deploying IoT systems. Ensuring that the data transmitted between devices is encrypted is essential to prevent eavesdropping and unauthorized access. Transport layer security, TLS, or secure socket layer, SSL, should be used to encrypt data transmitted over the internet. This is particularly important for web servers or cloud services where sensitive data is being sent. Using HTTPS instead of HTTP ensures that the communication is encrypted and protected from interception. To prevent unauthorized devices from accessing your IoT system, you need to implement authentication and authorization measures. At a basic level, ensuring that your IoT devices are protected by a strong, unique password is critical. Avoid using default credentials that can be guessed by attackers. For communication with cloud services or RESTful APIs, API keys should be used to authenticate devices and users. This prevents unauthorized access to your system and ensures that only verified devices can send or receive data. The security of IoT systems extends to the devices themselves. Ensuring that your devices are running up-to-date and secure firmware helps to prevent the exploitation of vulnerabilities. Failing to update your devices leaves them susceptible to attacks that exploit outdated software. Some IoT devices use secure bootloaders to ensure that only trusted firmware can be installed on the device. This prevents malicious code from being introduced into your system. Securing the network on which your IoT devices operate is another key aspect of system security. Use WPA3 or at least WPA2 encryption on your Wi-Fi network to prevent unauthorized access. Ensure that your network's password is strong and regularly changed. It is good practice to segment your IoT devices from your main network. For example, setting a separate network for your IoT devices reduces the risk that a compromised IoT device could provide access to more critical data systems or access to your primary network. As you continue to develop more advanced IoT systems, understanding communication protocols and implementing robust security measures will become increasingly important. Both MQTT and the RESTful API provide a powerful means for devices to communicate with each other, each with its own strengths depending on your use case. Just as critical is ensuring the security of your devices and the data they handle. By using secure communication channels, enforcing authentication, keeping devices updated, and securing your network, you can protect your system from a wide range of attacks. This lesson provides you with a fundamental understanding of IoT communication protocols and security considerations. These concepts will become invaluable as you expand your IoT projects, integrate new devices, and explore more complex and connected IoT ecosystems. Failing to update the devices leaves them susceptible. Failing to update your devices leaves them susceptible. My God.
Susceptible.
Susceptible. Failing to update your IoT device leaves them susceptible. Oh my God. Susceptible. Failing to update your devices leaves them susceptible. Failing to update your devices leaves them susceptible to attacks. That was too hard, dude. For no reason.